So I want you to imagine a paper shredder, but not a normal one. Imagine a paper shredder that pulls in a document, selectively vaporizes a single crucial word, and then leaves the rest of the page perfectly intact.
Oh, man. That sounds incredibly frustrating.
Right. You slide the paper in, the machine whirs, and it hands you back an almost pristine sheet. Except, for the one specific piece of data you actually needed.
Just gone.
Exactly. Poof. And today, we are doing a deep dive into a bug that was doing exactly that, but inside a text parser.
Yeah, and it's a really fascinating case study.
It really is. Our source for this deep dive is a remarkable piece of technical forensics. It was published today, actually, June 26, 2026, by a developer named Ang.
And we should mention the title. It's called Refining the Haskell Parser, Retaining Chapter Header Separators.
Yes. And the crazy part is it's remarkably part 171 of a series called Notes on Haskell Programming.
Which is just, wow. Documenting an ongoing project up to part 171, that implies a level of systemic, long-term debugging that is incredibly rare to see in public technical logs.
Yeah, you really don't see that kind of dedication every day. So our mission today for you listening is a true forensic examination of this single, highly specific programming bug.
Because the goal here isn't just to, look at lines of code. It's to understand the meticulous logic of parsing text.
Right, and how one tiny little function can make a crucial character just disappear. Teaser for you guys. This tiny bug involves a piece of code literally sending data into the void.
Literally. The function is actually called void.
We will definitely get to that. But before we jump into the Haskell code, let's establish the symptom first, because we need to look at what went wrong before we diagnose the disease. What exactly happened for Ang here?
Well, Ang was testing some text format outputs, specifically looking at how the software compiled plain text structures.
Okay, so just checking the final generated documents.
Exactly. And during this testing, Ang noticed that the chapter header separator, which is a very specific character in this context, was completely missing from the final document.
Just dropping out entirely. But we're not just talking about a normal, standard ASCII colon here, right?
No, not at all. Ang's post explicitly highlights that the missing character is a full-width colon.
A full-width colon, okay. I want to play devil's advocate for a second here because, some people listening might be thinking it's just one colon in a text file.
Right, who cares? Right.
Exactly. Why does a missing separator even matter in the grand scheme of a massive programming project?
I get that. But the distinction between a standard colon and a full-width colon, it fundamentally alters the structural integrity of the final document.
How so?
Well, in East Asian typography, specifically Chinese, Japanese, and Korean, what we call CJK text characters, occupy a uniform, square visual grid.
Like little blocks.
Exactly, like little blocks.
Yeah.
Now, a standard ASCII colon is proportional and narrow. It barely takes up any space.
Right.
But a full-width colon, which is represented specifically in the Unicode standard, it takes the exact same physical horizontal footprint as a complex Hansi character.
Oh, wow. Okay, so it's as wide as a whole letter, basically.
Exactly. So when you are outputting a raw text stream where visual hierarchy relies entirely on character width, like in a plain text document, dropping a full-width colon doesn't just remove a piece of punctuation.
It messes up the spacing of the whole line.
It completely collapses the typographic grid.
Yeah.
The text suddenly just crams together.
It reminds me of an airport security scanner.
Oh, how so?
Well, think about it. The machine detects the keys in your pocket, right? The software highlights the metal object on the operator's screen, so the system is fully aware the keys exist.
Right, it sees them.
But instead of returning them to you in the plastic bin at the end of the belt, the machine just silently disintegrates them.
That is a terrifying thought, but yes, mathematically that is exactly what is happening here.
The parser recognized the separator token in the input stream, but it just failed to push it to the output buffer.
Yeah, and that mechanism matching a token versus retaining its value is the core friction point when building parser combinators.
A parser combinator. Can you break that down real quick?
Sure. A parser's job is to traverse a stream of input, consume characters that match specific rules, and then update its internal state.
Like reading left to right and checking things off a list?
Exactly. Now, sometimes that state update involves building a data structure to pass along, but other times the parser only needs to verify that the syntax is valid without retaining the raw characters for downstream use.
Okay, so it's like saying, yep, I saw a space here, you can ignore it, just keep reading.
Spot on. But in Ang's case, the parser was successfully identifying the full-width colon in the Unicode stream, updating its positional state, but it was deliberately choosing not to retain that character for the output.
It was vaporizing the keys.
It was vaporizing the keys.
Okay, let's unpack this. Knowing what happened, we have to pop the hood and look at the actual code to figure out why it happened. Let's talk about the culprit.
The infamous void function.
Yes. In Ang's code, the specific function responsible for this bug is literally called void. And I want to read the original line of code from the post. It goes, pSeparator equals void, parentheses 1, offstring separators, parentheses, pipe hbase 1.
Right, so let's look at what void actually does in the context of Haskell. Because Haskell is a strongly typed functional language.
Meaning it's very strict about what kind of data goes where.
Extremely strict. Every expression has a specific type, and the compiler enforces the alignment of those types. So because a parser is a functor, the void function is used to discard the underlying value of an evaluation while keeping the context.
Okay, wait, what does that mean in plain English?
Basically, the source text tells us that void is a function that, quote, consumes the input but discards the result, return unit. Under the hood, it replaces whatever the parser found with an empty set of parentheses, which is the unit type.
So, if the parser finds the string, instead of returning a string type, it returns a unit type. It basically tells the compiler, hey, I consumed the input, I successfully moved my cursor forward, but return absolutely nothing of value to the rest of the program.
That is the exact functional mechanism, yeah.
I just have to marvel at the literalness of programming sometimes. The code did exactly what it was told to do. It found the separator string, sucked it into the void, and returned literally nothing.
Well, what's fascinating here is the logic of parsers. Sometimes programmers really do want to discard input.
Right, like we said earlier, ignoring extra spaces.
Exactly. But applying void to the chapter header separator here was a crucial logical error, because that character absolutely needed to be printed in the final document.
So why did they use it? I have to push back on the programmer's intent here, because the use of void almost seems like malicious compliance. Like they were just trying to shut the compiler up.
You're looking at that alternative operator, aren't you?
Yep, the little pipe bracket thing, the operator.
Mm.
In parser combinators, you're constantly evaluating alternative paths. It tries the parser on the left, and if that fails, it tries the parser on the right.
Right, that operator is central to monadic parsing. It defines fallback logic, like try to find this, but if you can't, do this instead.
And I'm guessing the programmer needed both sides of that fallback logic to return the exact same type.
Bingo.
So if the right side of the operator, which is hbase 1, if that just consumes horizontal white space and natively returns a unit type,
then the left side, the one finding the separator string, also has to return a unit type. If they don't match, the Haskell compiler throws a massive type mismatch error and just refuses to compile your program.
So they just slapped a void on the left side to force the types to align. They silenced the compiler without thinking about the data loss.
Yeah, that deduction hits on the harsh reality of day-to-day functional programming. The standard library parsers that handle space usually return unit. To make the separator parser compatible, they used void as a type matching convenience.
Wow. You satisfy the type checker, the code compiles perfectly, no runtime errors. But you've just instructed your program to selectively assassinate essential formatting data.
It's mathematically sound, but logically flawed. The compiler can verify the types match, but it has no way of knowing that dropping that full-width colon violates the semantic intent of the author's document.
That is wild. Okay, so to fully grasp why that full-width colon was so vital to the semantic intent, we have to zoom out a bit. We need to dissect the parsing environment.
Right. How is this parser actually reading the document?
Yeah, how does it know where it is? Because it isn't just hunting for punctuation at random. Ang provides a larger code block in the post called pNumbered header type level units.
And that block dictates how the parser reads an entire section header. If we look at the structure of that code block, it really reveals how parsers manage contextual ambiguity.
Like how it figures out what's a header and what's just a normal sentence.
Exactly. The first operation Ang highlights is look ahead, which is combined with a function that takes characters until it hits a new line, so A.
Oh, so it's buffering the entire line of text first.
Yes.
I assume that's for establishing boundaries. Like, if the parser is looking for a specific header structure, you don't want it accidentally bleeding over and eating the first paragraph of the actual chapter if the formatting is weird.
Exactly. Buffering is a critical defensive measure. It lets the parser evaluate the entire line as one contained unit.
Okay, so it gets the line, then what?
Then, if the sequence of parsers fails to match the header pattern, the combinator can just backtrack. It resets its position without having destroyed the input stream.
That makes sense.
But if it succeeds, It establishes the start marker, and then it switches contexts to process the chapter number. And this is where it gets really interesting. It uses a variable called num, and the function it calls is Chinese numeral or digit.
Wait, is Chinese numeral or digit?
Yep.
That specific detail. That is the smoking gun for our full-width colon. Because a standard English text parser generally just looks for ASCII digits, 0 through 9. But Ang's parser is explicitly engineered for internationalization. It's looking for Hanzi numerals. Does this show how parsers have to be custom-tailored to the specific language and typography they're dealing with?
Oh, absolutely. If we connect this to the bigger picture, text parsing isn't just about English alphanumeric characters. Parsing CJK characters introduces a totally distinct set of challenges regarding Unicode boundary.
Because the numbers are in a different place in the code.
Right. If you execute a naive digit parser on a document written in Chinese, it will fail to recognize the chapter enumeration entirely. The character ranges for Hanzi numbers reside in a completely different block of the Unicode standard than Western Arabic numerals.
So you have to explicitly instruct the parser, hey, the concept of a number right now includes these alternate Unicode blocks.
Yes. And because of that, the parser also has to expect typography native to those blocks.
Which explains the colon. If the chapter number is a Chinese numeral, the separator following it isn't going to give a thin ASCII colon. It's going to be the full-width colon we were talking about earlier.
Exactly. The typography rules literally change depending on the language state the parser is currently in.
And the tragic part is the parser was actually executing that state transition perfectly.
It really was.
Think about it. It peeked ahead. It isolated the line to prevent overconsumption. It successfully identified the start marker. It accurately parsed a Chinese numeral using custom Unicode logic.
It identified the structural unit string, like the character for chapter.
And then it reached the separator logic. And at that exact moment, the parser executed the void function, took the full-width colon it had just perfectly contextualized, and threw it into the void.
It did 99% of the heavy lifting flawlessly, navigating complex cross-lingual typography, only to fumble the ball on the 1-yard line because of a single type-matching shortcut.
Unbelievable. Okay, so we understand the error, and we understand the highly specific, internationalized environment the parser was operating in. How did Ang actually engineer the elegant cure for this?
Well, the solution Ang implements is documented in the code diff in the post, and it's a brilliant example of refactoring for state retention.
Okay, let's look at the after side of the code changes. I'll read it. The void is stripped out entirely. The new code is pSeparator equals one offstring separators, pipe parentheses, quote, space, quote, $ less than h space 1 parentheses.
Okay, let's break that new syntax down. By removing void, the parser on the left side of the alternative operator now returns a string, which is the actual separator character it matched from the text.
Right, but because of the type constraint we talked about earlier, the right side of the operator must also return a string now, instead of a unit type.
Exactly, and that's where that new piece of syntax comes in, the operator.
That's the left-pointing functor map, right?
Correct. It replaces the result of the parser on its right with the constant value provided on its left.
Okay, so if the parser hits the h space 1 condition, meaning it didn't find a colon, it just found a block of empty white space.
It consumes that varied horizontal space from the input stream and normalizes it into a single standard space string.
Oh, that's clever. Because of this, both sides of the operator now return a string.
Yes, which perfectly satisfies the Haskell type checker while ensuring that no structural data is lost in the process.
So what does this all mean for the rest of Ang's code? Ang notes that this final polish allowed them to, quote, capture the separator into sep?
Right. Once the full-width colon is bound to a variable, in this case sep, it is safe. It isn't just a consumed token anymore. It's retained data.
Data that can actually be passed down the parser chain and injected into the final output document. But there's a second part to Ang's notes here that I really want to touch on. Ang mentions having to, quote, replace the original hard-coded single space with optional separate if a separator was found.
Yeah, that part is really telling about how bugs compound. The original implementation was basically a blunt force, destructive solution to the problem it created.
Because the full-width colon was being actively destroyed by void, the final output would have just slammed the chapter number and the chapter title together into a single unreadable string.
Exactly. Chapter 1 introduction, all is one word. To prevent that visual collision, the previous code arbitrarily hard-coded a standard ASCII space into the output structure, regardless of what was actually in the source text.
Oh, man. If you've ever built a web scraper or dealt with messy data ingestion, you know that exact temptation. You pull in unstructured data, you realize handling the native formatting edge cases is just too complex, so you strip out the original separators and just hard code a generic space or a dash between your variables.
Just so the output looks clean to you.
Right. It's like a primitive, aggressive autocorrect
Yeah.
that continually overwrites custom typography with generic defaults.
And in this context, hard-coding an ASCII space in a parser designed to handle CJK text is a critical design failure.
Because it forces Western typographic norms onto an Eastern grid.
Exactly. It forces proportional spacing norms onto a structure that relies on grid-based alignment. But by capturing the actual full-width colon into the sep variable, the parser now dynamically reacts to the source material.
So if the author utilized a full-width colon, the parser retains and outputs the full-width colon.
Yes. And if the author omitted a separator and just relied on spacing, the functor map normalizes it gracefully.
The text itself dictates the formatting, rather than a lazy assumption hard-coded into the parser's output logic.
Which is exactly how a robust parser should behave.
So stepping back to look at this entire forensic breakdown, it really is a testament to the microscopic precision required in software engineering.
It really is.
Aang encountered a formatting anomaly where a document's typographic grid was collapsing. And by tracing the execution state, Aang realized that a type match inconvenience, just throwing the void function in there, was quietly dropping essential Unicode data to satisfy the compiler.
But by refactoring the functor mapping to retain the string, binding it to a variable, and stripping out that generic hard-coded space, the parser regained its integrity.
It now fully respects the complex typographic environment of Chinese numerals, guaranteeing that the full-width colon makes it out of the text buffer and into the final compiled document.
And Aang just closes the post with a simple, "Till the next post. Yours truly, Aang."
Another successful debugging session in the books.
It's a quiet conclusion to a deeply structural fix. When you modify how a parser combinator handles state and type constraints, you aren't just fixing a superficial typo. You're repairing the foundational logic of how the system interprets and translates human language.
Well said. And that leads me to a final provocative thought. I want you, the listener, to mull over today. The next time you are reading a perfectly formatted digital document, whether it's an ebook or a TXT file, especially one that handles internationalized text, varied character sets, or complex grid typography.
Take a second to think about what's going on behind the scenes.
Exactly. Think about the unseen microscopic layers of parsing logic. Think about the thousands of parser combinators peeking ahead, managing state, and navigating strict type constraints, all working tirelessly to ensure that every single character, every full-width separator, and every unit of typographic structure actually makes it to your screen, without being mapped to nothing and accidentally swallowed by the void. Thank you so much for joining us on this deep dive.